Okay, so thank goodness we are on to plastic finishes, and even more thank goodness is the fact that there's not many things you can do with plastics in terms of finishing. They are largely what we would call self-finishing. Right, let's have a look at this. Okay, you can paint plastic if you really want to. Say if you have a 3D print that you get out of the 3D printer. Here we go. Let's draw a lovely. So imagine this is like a cone-shaped cylinder. Now, let's say you didn't want it to be blue. You wanted it to be a lovely shade of green, for example. You could then spray paint that with like acrylic paint to get that the color you wanted it to be. So yeah, that's totally doable. But you'd have to employ the same method as we use for metals. So you'd need to put on a layer of primer first, and then you'd need to put on a layer of, primer, then sand, and then prime again, etc. And you repeat that process until you achieve the desired finish, and then you put on the top coat of whatever you want the color to be. So that you can do. Yeah, and that covers the sort of the acrylic paint section. Now the other one is pigmentation. So the DeWalt drill here, this would have been colored using pigmentation. Now what pigments do is, as the plastic granules are fed into the hopper of the injection molding tool. So here we go, there's the injection molding tool and the hopper in the top here, and it goes into the Archimedes screw through here, and it's melted along the way as it goes through the machine. Now, what will happen is the plastic granules are inside the hopper, and they're gradually fed down and they're melted as they go along the Archimedes screw here. Now, what they do is they will add color or pigmentation in the form of a powder to this. So they'll add in like powder pigment, and as that melts and mixes and the Archimedes screw moves it around, it will gradually change the color of the polymer to become then the color that you want to have, which is then injected into the mold tool after that. So that's pigmentation. Now, pigments are great because they are literally embedded into the entire section of the plastic. If you took a slice through that DeWalt drill, the plastic would be as yellow on the inside as it is on the outside. Even if you got some sandpaper and you sanded away at it furiously, it would still be yellow. You can't get rid of that color. Whereas with paints, you can easily end up chipping paints. You can accidentally, like, I don't know, you can even like rub it off. Like, I mean, my bicycle at home is carbon fiber, and it's got a few layers of paint over the top, but there's a bit where the tire has been rubbing against the frame, and that's gradually worn away at the paint. So it's kind of annoying. So pigmentation, wherever possible, that's actually the preferable way of coloring something. Now, another one is what's called overmoldings. Now, these can be done with either TPRs. TPRs are thermoplastic rubbers, or TPUs, which is thermoplastic urethane, not thermoplastic urethane. That is thermopolyurethane. Yes. So these are both rubber. I mean, if you watch the videos on materials, these are both rubbers, or they're both sort of polymer-based rubbers, but this one is a thermoset, and then the other one is a thermoplastic. So the thermoset is obviously it can't be melted. So it's good for like high temperature applications. So the way these work are, the yellow section of the drill would be molded first in the injection molding tool. Once it's hardened and set, it's then ejected from that tool, and it's moved straight away whilst it's still hot into another injection molding tool, which has then the cavities for the black rubber sections on the outside. And it will then block off, it'll like mask off the areas that you want to keep yellow. Then it will inject in the TPR, which is black. This will be a TPR in this instance. And then the heat of the two polymers will just automatically bind them together. You don't need glue to do it, which is great. So it uses heat to join. Oh, look at that lovely handwriting. My goodness me. Yes, so very nice. It makes for an incredibly durable, like a crazy durable grip. And that's the advantage is you can see this has this sort of aesthetic property. You get what's called a color split doing this method. But you also get a grip. I mean, another really annoying as in it's annoyingly over-designed are toothbrushes. Toothbrushes are like the most over-designed things in the world. They are ridiculous. You look at the amount of like different grips and soft sections and like grippy textures, you think it's a toothbrush. It's not a heavy It's not a heavy product that you have to pick up and you need grip on, you need purchase on it. It's so funny. So they do that purely for aesthetic reasons. And the last one is pad printing. Pad printing is how they put on things like the logo on. So what they'll have is, I mean, this is plastic that's been embossed, and then they will literally just have a solid pad of ink, which will then just be padded down onto that embossed section, which will automatically then just project the DeWalt word there. However, ones like these numbers here, what happens is you'd have a pad, say, which might be a sort of semicircular. Here it goes, the world's best drawing. Or it might be slightly curved like this, and it's made of a sort of spongy material. Now, what this does is this has the number 15 written on there, but it's sort of written the wrong way around. So, yeah, you'd see... I say the wrong way around. I can't even draw it the wrong way around. Okay, so... Oh, there we go. Lovely. Look at that. So, you'd have 15... written like that, and these would be slightly raised up off the surface of the rubber stamp. This literally is how rubber ink stamps work as well. And what these do is the rubber stamp itself is first used to pick up the ink that's going to be then transferred. Then that is just like padded, because it's soft, it will just pad onto like anywhere that you want that to be applied. And they always use very durable, very hard wearing inks that are put on there. Oh, thank goodness for that. That's the end of plastics. A nice short section there, and then we're just on to the last one.